better services are better ways of doing these calculations and things.
Yeah, that's sort of a feature of our team that we do hire a fair number of former domain scientists who've gotten into the HPC space. So I think everyone on my team is a former researcher of some stripe or another that is able to really talk to the researchers and understand the pressures of trying to publish research. And
Welcome to Embracing Digital Transformation, where we investigate effective change leveraging people, process, and technology.
This is Darren Pulsford, Chief Solution Architect, author, and most importantly, your host.
On today's episode, optimizing HPC usage for researchers, with special guest Eric Coulter, researcher and HPC wrangler at Georgia Tech.
Eric, welcome to the show.
Thanks, Darren. Happy to be here.
Hey, I had the opportunity of talking to your cohort, Aaron. Now I want to hear the other side of the story. But before we get started, all of my guests are superheroes because I wouldn't have anyone less than a superhero on the show. But every superhero has a backstory. Eric, what's your backstory?
Okay, I'll do my best. Superheroes a bit more than I would put my name to, but I appreciate it. I appreciate the confidence. So I started out, I guess I'll start from when I was in grad school. I was doing condensed matter physics research at Florida State University. And we were looking at trying to do theoretical calculations of the optical properties of certain materials to see if they could be good candidates for things like solar cells or very sensitive photodetectors. And I was a grad student that had Linux experience and had a little bit of
you're
hands-on.
dangerous then.
Right, exactly. And so my advisor was largely on the theoretical side, and we were moving into a world where we needed more computational resources. And we found that some of the central university resources were not a great fit for the large memory needs that we had, and we ended up buying our own nodes, which we do not encourage today in my current role at all. Please don't do this. And we
No, wait. I work for Intel. Everyone buy as many nodes as you want.
You can buy the nodes, but
just make sure they're Xeon processors. That's all I care about.
Let our team help you manage them and put them in ours.
Yes, there you go.
Because you get people like me who, I became the grad student that was running our little mini cluster for our lab, and it was a lot of fun. I learned a lot. I got to do a lot of things. I ended up helping other people come onto our system and do their research. It's like, oh, this is a lot of fun. I don't have to deal with journal editors. So when I finished my PhD there, I found a role with Indiana University, and under the Exceed program, which is now called the Access program. It's a big NSF collaboration between, trying to share compute resources across anybody in the U.S. that the NSF wants to help, basically. So I had a role there on the team that was actually going out to smaller institutions and helping them build their first clusters to support local users, with the goal that more campus clusters means more education of people using them correctly, more people building and running them, more people able to transfer up to the large national scale systems, which was a lot of fun.
It's interesting because your journey is similar to Aaron's journey, who I talked to. He's a nuclear physicist. You're a materials physicist,
roughly
in that realm. Both PhDs, now both doing cluster work, right?
Yeah,
I think it's funny. I
mean, it is. I mean, you run into a lot of people in the HPC space that are former scientists of some stripe. Physicists are fairly common.
Yeah.
And it's funny too, because physicists also have a reputation among HPC admins for being the people that cause you headaches because they're trying to do crazy things on the system.
So now that you're on the other side, on the more IT side, do the physicists still give you grief? Are they the ones that give you the most grief? Or you understand them? So
I understand where they're coming from. So I understand why they're doing the things they're doing, and now I understand why central services are doing the things they're doing. So. I'm trying to be that bridge and help
The
everyone
bridge
get
in
their work
between.
done
So
effectively, right?
that makes you invaluable, actually.
I I hope I'm valuable.
Yeah,
Yeah.
yeah, yeah.
But yeah,
So
it's very
so
rewarding being able to sort of speak both sides.
well, and that puts you in a unique position because you can speak both sides. You understand what their real needs are instead of it just because what physicists and other researchers need is not just a bunch of raw computers. Ultimately, they need something else, right? They need some results out of it.
Yeah.
So you're very much more results focused than, oh, I just have a bunch of hardware and networking and all that stuff. So which gives you a unique perspective.
Yeah, very much so. It's there's an understanding that it's not about, building the perfect pieces of code, building the perfect services that are never going to fall over. It's a research space. You need the result. You don't need it to be
Pretty.
perfectly polished and featureful.
Yeah.
I need this calculation to run so I can make this figure for my paper. Done.
Well,
I
you
need
know
to make
what?
these
That
measurements.
that perspective you brought over into central services into the IT world, which is probably helping them understand better and provide better services or better ways of doing these calculations and things.
Yeah, that's sort of a feature of our team that we do hire a fair number of former domain scientists who've gotten into the HPC space. So I think everyone on my team is a former researcher of some stripe or another that is able to really talk to the researchers and understand the pressures of trying to publish research and the actual needs versus, okay, I want this thing to run perfectly and be very pretty.
Turn that around a little bit. How can you help those researchers? What do you bring to them? Because you've already brought to central services a way of operating, a better way of operating, because you understand. But ultimately, your um, job or desire or passion is to help researchers do their jobs more effectively,
Exactly.
right? So what does that look like? If I'm a brand new researcher, and let's say I'm in a field where I don't do a lot of computer stuff, I'm, theoretical physicist or theoretical biologist. I don't know. We'll dream up something, right? A theoretical nanobot guy, whatever. And I come to you and say, I really have heard about HPC, and I've got this big problem that I can massively parallelize, I think. How do I start? So I come to you, Eric, and you go, yeah, you need to go take a CS degree and figure this out, right?
Yeah, basically, yeah, go figure it out, like we all had to. No, no, it's very much, we have regular workshops that we run to sort of help people get onboarded onto like what a cluster is. What does it look like specifically at Georgia Tech? How does it work coming and using a command line environment so that you can actually interact with these systems in the most powerful way? We have sort of the easy mode of the web interfaces that let you get started. And there's a lot of power there. I don't mean to say you can't do things through the web interface. It's very flexible and it gives you Jupyter notebook
But we all know the
interfaces.
command line is where it's at.
That's where we live,
Right
right?
there.
Yeah.
Yeah. Yeah.
You know,
No, I hear
I
you.
want to feel like I'm working on a VT100 terminal.
VT100 terminal.
Yeah.
Do you remember those?
No, I just
Yeah.
just reputationally by the constraints of the 80
Oh
the 80
gosh, I'm an
character
old
limit.
man
Yeah.
then.
I never touched one, but
Oh gosh. Yeah. Yeah. 80 characters across 43 rows
yeah.
per.
And it's
Yeah.
still
VT
there. Like
100.
all that history persists, and I think a lot of the value that we bring is knowing, being familiar and comfortable with the guts of that stuff and being able to say, okay, I know this looks weird. Here are these commands that you're going to need to learn. Here's how you find help when you're on the system. Here's manual pages. Like here's what the scheduler is doing. Here's what we mean when we talk about compute nodes and how parallelization works at a physical level. and being able to
So
help.
a small primer in Linux is probably valuable
Yes,
for a lot of people, right?
very
Because the
much
command
so.
line is running probably Bash would be my guess on
That's
a
our
Linux
default.
box. So yeah, some basic commands so that they know where to find their files, how to look at their files. Um,
Yeah,
that makes sense.
and
That's the foundation. That's the go do this first
yeah, pretty
and then
much.
come back to me.
I mean, yeah, we do as much teaching in that direction as we can, but that if people really, you have to engage with that yourself to some degree. It's not something someone can just hand you completely.
Right,
It's like my
right.
my advisor
So
always said, you have to, like doing practice problems in physics, you have to do it until it's in your blood. And it's kind of the same with computing, until you know you've had the time and been exposed to the concepts. And I think we're trying to do that in a friendly way.
now,
Ex-
how much do I need to invest of time in order to do this? Are there any? You said there's a web interface, so
mhm,
there is an easy button
mhm,
if I really just want to focus on genomics. I don't want to learn all the
right. And
and
that's on
you know
purpose.
I give you my calculation, I get my response back. That's what I want, right?
Right. And I get it. Because if you spend all the time, you end up coming to HPC. You don't always continue doing science. And we want people who are trying to do science to be able to continue doing science.
Yes, we need people doing fundamental research still.
Yeah.
Yeah, we
But we also need those people to get exposed to Linux and come to our side too.
a little bit.
A
Yeah, yeah,
little, just a
yeah.
little bit. Um, but yeah, the easy button is very important. Like we have these we have different interfaces. We have Jupyter notebooks that people can run on the cluster without having to know about the scheduler. There's a very powerful tool around it called Open On Demand that we run that interfaces natively with our scheduling system and lets people run a desktop, but it's on the cluster. Or they can start a Jupyter notebook with access to however many actual compute nodes they need, and split their job out, provided they've written their code correctly. And so that's the thing. It's an easy button, but it's very easy to get it to miss the underlying features if you don't really know something about what's going on. So we try to expose enough of it so that people can do things correctly. Because you have the people that fire up like, hey, I just started a job with 5 GPU nodes, not just GPUs. And then you go and look, and nothing is happening except for on the main node of the job, because they haven't actually interfaced with the scheduler correctly or something like that in their code. And you want to avoid that because people end up paying for those resources in a cost recovery environment, like we're running. So we're trying to help people do the right thing and also get the most bang for their research dollar.
All right, so it's not so you guys offer services not just go to the website and use it. You also offer consulting services for these researchers and say this is how you need to set up your algorithms because they've probably done this on a Jupyter notebook on their laptop or on
Or
a workstation.
or like in Google Colab or something like that, yeah, where it's
Yeah.
very much running on a single machine in the back end. It's just going out. It's not, hey, I'm running on 5 different machines and actually trying to split this out, fully parallelized across distributed memory systems.
But which that's a different way of thinking about compute,
Yeah,
right? I mean, that's very different.
yeah, very much so. And that's, we
So
do we do provide
this
that
is where you can bring
consulting.
your expertise to help them,
Hmm.
right?
Yeah, and the hard part is making sure that people know we exist and they can come to us with problems. Um, a lot of it does end up being sort of, hey, I can't log in. Can you help us? Like we have our very frontline people who help with that stuff, but then it becomes, oh, I'm trying to run a job. How do I do that? Please come to our classes. We do have regular office hours, and I think that's really where the deeper engagement really happens as people come and say, hey, I'm trying to run this thing. How do I do that? Let's look at whether or not you're
Are
using all your
researchers, are
resources.
they, yeah, are researchers willing to open up the kimono to you guys? Because I know sometimes in research,
It's tough.
right, I don't want
It's
to share
tough.
my algorithm, right, or my data because, you know, I've got to publish.
Hmm.
You publish or die, right?
Yeah.
Isn't that,
Yeah.
you
Yeah.
know,
Publish or perish. Yeah.
yeah, publish or perish. And so I, you know, is there any, and how do you overcome that trepidation that maybe some researchers have, or does it even exist?
It exists to some degree. I think some of it is helping people understand that we do understand the research life cycle, casually letting it slip that we previously did research in a different life, right? Um, building sort of breaking down that fear because it does exist. A lot of times, sometimes it's just students, sometimes it's more with the PIs where there's like, oh, I don't. Do we really want to work with you guys? What do you know? You're central IT because we are under the umbrella of central IT. We're not on the research side of the institution. Um, so we have to,
So they don't see you as being knowledgeable
right?
or, you know,
Yeah, like
well,
previous.
maybe what you need to do is walk around with all your papers that you've written kind of in a cloud around you so people can say, oh, I want to talk to that guy over there because I know he knows what he's talking about.
Oh, that's funny. Yeah, it's you have to do a little bit of that signaling to get through. Like I used to be very staunchly against signing my emails that I have a PhD, and I have now changed that because it does help break down that barrier when you're dealing with faculty members a little bit.
Oh, that's interesting. But you know, but I think it's true. I mean, when you see someone's credentials,
Hmm.
whatever they may be, especially if it's a PhD in physics and you're talking to another physicist, they're going to go, wait, he's going to understand when I talk about, you know, my computational problem that I have. He has context.
Yeah, exactly. It's about having that shared context, and even with other researchers, you can say, well, I have my background's in this field, but I know how the computational systems work. I'm familiar with the pressures of the publishing life cycle that you're under. We can help you. We can help you with this at a deep level. Um, Even though a lot of the times it's a lot of the things that people are struggling with are interface related. It's the command line. It's using all of the machines that you need through the easy button interfaces. Um,
Have you ever had the opposite happen where someone accidentally fired up, you know, 1,000 machines
oh yeah,
to run something?
yeah. Actually, this was a really fun one that happened recently. Um, this it was a there was someone wrote a loop in their script, and in the loop it resubmitted the job itself because the file name was and it spun up immediately 500 copies of itself, and they were all doing nothing. And
Except spinning up themselves,
yeah,
right?
exactly, and it actually managed to slow down the scheduler, which was fascinating. It was a great stress test. I keep that as an example of
Oh, yeah, that's a great one. That reminds me, I used to run a lab when I was in undergraduate,
mhm.
and I could always tell this when the class that was learning C learned about while loops and fork, because a while one fork
Yep,
brought a machine to its knees. So, but imagine doing that on a cluster.
yeah,
Um,
it was
luckily, the
fascinating.
scheduler's there to to take the brunt of it.
Right. Yeah, the scheduler really took the brunt, and it was. I was like, why is this person running 500 jobs? Oh, these are all the. Oh, that file is. it's self-referential. Great. Um, but people are like, yeah, we're trying to submit jobs and it's going really slow. What's going on? And there's like on the compute side, there was hardly any load. It was the scheduler itself, um, which was really really fascinating and never happened before. Um, and we,
Now, you mentioned. Oh, go ahead.
Uh, sometimes we have the problem where people with the physicists where they have a very complex workflow and they hand us these scripts and it's like, oh, what are you doing? And it actually takes a lot of sleuthing to understand where in their whole workflow problems are coming up. And I think the thing we hear the most is, this used to work at my old institution. Why isn't it working here? Like, well, you're on a different system. Let's work through this.
They probably have hard-coded data
Yep.
paths, maybe even hard-coded IP addresses of different services talking to each other or getting information.
Yeah, you run across things like that.
Now, you mentioned earlier a lot of people that you work with are previous researchers in different domains.
Mhm.
So when you guys have someone come in, do you have a way of like triaging, hey, this one is from life sciences, we'll send that over to, Dr. Life Science over there instead of Dr. Physicist. Is that something that you proactively do, or do you just say, hey, this one looks interesting, who wants it?
Oh no, we absolutely do. It's a lot of times it's more of what software we're all familiar with. Like
Oh, okay.
we have a guy who's doing neuroscience research who's very, very happy with R. So all the R questions go his way. And
Oh, they are. Yeah, gotcha.
I have a one team member who's newer was doing food science research, which is a very interesting sort of intersection of chemistry and biology. So she's getting a lot of our softer life sciences related questions. We do.
Have you guys stood up any like best practices geared towards towards the different, well, not software stacks, but kind of software stacks, because
It kind of is,
like
yeah.
bio life sciences all kind of use a set of software that they all use, right? I
Yeah,
mean, that's
yeah. There's, we have we maintain a software stack in collaboration with our software team. Um, so there is a centrally supported stack, and there's sort of different paths within that tree of software, because it's a tree structure, because there's different compilers that we maintain. There's different implementations of MPI libraries, message passing interface, which is sort of the base language for parallelizing across many nodes
right.
for a lot of these domain softwares. But then you also have the different Python packages and package managers that we maintain.
Oh gosh.
So yeah, there are sort of, we really base it more around this particular software than specific domains, because there is a fair amount of crosstalk between domains. I do think that would be very interesting, though, to have some sort of domain-specific user groups or something like that.
So right now you guys are mostly software stack based, which makes sense, right? Because you can get scalability. Does that mean that I can come on to the Pace cluster and say, "Hey, I'm going to be doing something with I don't know the tools. Let's say MATLAB, because I know that one from way back when." Right? You have a stack all ready to go. You could say, "Hey, Darren, we can jumpstart you. Here you go," and
Oh yeah,
is that how it works?
absolutely, yeah. If people actually come to us and ask. A lot we haven't there's enough documentation out there that I think a lot of people sort of try to jump in feet first and just go spin things up, and there's a lot of shared knowledge between lab members. But absolutely, I'd say, yeah, Darren, come on, go to your web browser. We're going to go to on demand. Here's a virtual desktop. You can launch your MATLAB and go to town. When you need to scale up, come talk to us again, please.
Instead of you floundering or causing problems or
Right.
spending gobs of money on the cluster, right? That
Yes. Yeah.
yeah.
We
When
we
I go
try
to my
to.
department chair, why'd you spend $10,000 last week on the cluster? I
Oh,
didn't know I did.
yeah.
Right?
Whoops.
Yeah.
Yeah. So it's we try to point those failure modes out early. Say, hey, make sure you know how many nodes you can actually use in this box. Um, if you really need to scale up again, like if this isn't enough, come back and talk to us, and we'll help you work it out. And
So was this the way you guys organize and everything? Did it kind of just happen ad hoc? You learned over the years, or was it planned? Because when I talked to Aaron, it was like everything grew ad hoc, and then they said, let's take the opportunity during COVID to clean up this mess and drop in, something more thoughtful, thought out, on the hardware side. But on the process side and the helping and the software stack side, does obviously it grows organically? Have you guys had the chance to step back a little bit and say, hey, we now have these buckets and get organized, or is it still ad hoc?
That's an interesting question. I think,
is it the nature of research to kind of be more ad hoc? Like you said before, it doesn't need to be perfect. I just need a result on the back end.
Yeah,
no pretty web interface.
Very, very much so. I think we are a little bit ad hoc and flexible in response to the nature of the environment we're in. We bring that enterprise perspective. We want this thing to be up all the time. We do not want researchers to have times when it's down and they come screaming, "Why can't I do my work?" We try to avoid that as much as we humanly can.
Yeah.
But yeah, the whole structure of it, I think, I came in sort of just after. I guess it was in late 2021. It was when things were still the pandemic was still in progress at that point, I think. But it was right in the sort of the middle end of it, and so it was after some of the reorganization at PACE had taken place, and there was deliberately a faculty outreach and interaction team, which is very similar to what we call the research computing facilitation team now. We sort of gradually moved things around a little bit within as far as who's managing what types of things, sort of in response to who we have and the needs that are coming in from the researchers. But I think there's a strong trend in the HPC, the academic HPC community, to provide those kind of services for researchers because it's very needed. There was I don't remember exactly when this started, mid 2010s, maybe early 2000s, a program called ACI Ref that started up and sort of started a trend of training the trainers. They were trying to build a national cohort starting, at small levels of what they call, this was when the term research computing facilitator was new, and they were trying to go out and create people that could do this, interfacing with researchers, bringing them onto the systems. And I think through the success of that program and a few others, sharing those at the academic HPC conferences, it's really turned into a very recognized component of a successful center, that you have people whose job it is to bring people on, help them run. So many of the people that are doing the actual research work are grad students. The PIs are managing the labs, they're managing their students, they're managing grants, they're teaching courses. It's the students that are coming onto the machines and learning how to use it. And so you need people who've been there, who started out. What's Linux?
And can help them along.
Yeah.
This whole thing is really fascinating. You've got to stay flexible, but it's also structured. So it's a new approach that I think is making some good inroads. It sounds like.
Yeah, and it's working very well. We have, and I think our team at PACE sort of reflects that dichotomy very well, because we have our cyber infrastructure team who's actually managing the hardware and keeping the storage happy and keeping things running and dealing with the networking. And a lot of them do come from a much more enterprise background where the focus is reliability, stability. And then you have you have the researchers who are coming in whose previous experiences with sort of closet clusters. It's like, yeah, well, we'll turn it on and do the research and call it a day and not worry about making it good for.
If it gets too hot in the closet that I jammed it into, I'll open the door.
Yeah. Hey, the closet has an AC vent. Let's make sure that's running.
Yeah, exactly. So,
Yeah.
so this is really good. You fit that gap in between enterprise IT, which is focused on different things, and researchers, which are, hey, I've got my job is to produce papers and research, right?
Mm-hmm.
Not to manage clusters, but anytime I talk to IT, they go, "Oh, you got to fill out all these forms, and it's going to take 4 months." And I'm like, I just need a number. I just need a number. That's all I need is a number from my algorithm. So I think you have a really important role of bridging that gap between the end user and the researcher and the IT organization that it's all about hardware. So
yeah, it's an interesting place to be in, and we get the thrill of seeing what people are doing for their research occasionally when we're able to get past the barriers, right?
Yeah, that's a good question. How much do they let you see? Or do they say, you know what, you can read it in my paper once it's published?
People will tell us a little bit, but they're really usually very focused on fixing the problem, getting back to work. And we have aspirations of being able to send people to really interface with the lab and actually get involved in some of the research at the level that we really can. But it's very challenging because you do have to get people to come and say, hey, can you come work with us on this? And I think it's a mix of, oh, why would I do that? Those are IT people. It's a mix of we don't need anyone else. Our grad students can figure this out. And it's also a problem on our end. I mean, we have a team of 5, including myself, supporting roughly 1,800 active users on our research cluster in a given year. I mean, we can't afford the time always to fully get onto that side either because of the scale that we're serving. So we do the best we can.
No, it sounds like invaluable. Eric, this has been a wonderful conversation. You've opened up my mind to a whole new way of thinking about HPC clusters, and obviously you play an extremely important role. So thank you for coming on the show.
Yeah, of course. I'm happy to be here. Thanks for having me.
Thank you for listening to Embracing Digital Transformation today. If you enjoyed our podcast, give it 5 stars on your favorite podcasting site or YouTube channel. You can find out more information about Embracing Digital Transformation at embracingdigital.org. Until next time, go out and embrace the digital revolution.